So here we need to find the sum of each of the following arithmetic progression. So let's begin with problem number 1. So in order to find out the sum of this particular arithmetic progression, we will use the formula. The sum of the n terms of an arithmetic progression is given by the formula n over 2 multiplied to the first term added to the last term. So that means we'll have to find, so here we have the first term, which is 2. Our last term is going to be 182. We'll need to find out the value of n here. So for finding out the value of n, we will use the formula an equals to a plus n minus 1 times d. So here a represents the first term, d is going to be the common difference. So for our particular problem, so here our first term is given by 2, and the common difference will be, we'll consider the second term, and from it we are going to subtract the first term. So 5 minus 2 is going to give us positive 3. So this is going to be the common difference. And our last term, which is also the nth term, that's 182. Now we can use the formula an equals to a plus n minus 1 times d. So in place of an, we have 182. So this will be equals to the first term, which is 2, plus n minus 1 times the common difference, d, which is 3. So that means we can solve this particular equation to obtain the value of n, which will be the number of terms in this particular arithmetic progression. So I have 182 minus 2, that will be 180, which is equals to n minus 1 times 3. Or simply, n minus 1 will be equals to 180 divided by 3. Now 180 divided by 3, that's 60. So n will be equals to 1 plus 60, which is 61. So that means we have 61 terms in this particular arithmetic progression. Now that we have the value of n, we can obtain our sum. So our sum will be sum up to the 61 terms, which will be equals to 61 divided by 2, all multiplied to 2 plus 182. So that gives us the value 61 over 2 multiplied to 184, which is 61 multiplied to 92. So 61 times 92. So this is going to be equals to 5612. So this is the sum of the given arithmetic progression. Now let's move on to the next problem. So let's find out the sum of this particular arithmetic progression. So here we have our first term, which is 101. Then we have a common difference. The common difference will be 99 minus 101. This will be negative 2. And our last term in the progression is 47. So that means when I will use the formula an equals to a plus n minus 1 times d. So here an, the last term is 47. That's equals to the first term, which is 101, plus n minus 1 times negative 2, the common difference. So we have 47 minus 101, which is equals to n minus 1 times negative 2. So 47 minus 101, that's going to be negative 54, which is equals to negative 2 multiplied to n minus 1, or simply n minus 1 equals to 54 divided by 2. So 54 divided by 2, that will be 27, or simply n value will be equals to 28. So that means we have 28 terms in the given arithmetic progression. Now that we have the value of n, we can easily obtain the sum up to the 28 terms. So that will be 28 over 2 multiplied to the first term plus the last term. So we have 28 over 2, so that's going to be 14 multiplied to, so 47 plus 101, which is going to be 148, and this is going to give us a value 2072. So let's move on to the next problem. So let's find out the sum of the given arithmetic progression. So here we have our first term, a with 72. Our common difference will be 69 minus 72. So that will be negative 3. And the last term, or the nth term, is 33. So using this, we can obtain the n value. So 33 will be equals to 72 plus n minus 1 times negative 3. Which have 33 minus 72, which will be equals to negative 39, which will be equals to n minus 1 times negative 3, or simply n minus 1 equals to 39 divided by 3. So 39 divided by 3, that's 13, and n value is going to be equals to 14. So now that we have the number of terms, so S14 will be equals to 14 divided by 2 multiplied to 72 plus 33. 14 divided by 2, so this is going to be 7 multiplied to 72 plus 33, so we have 105. So this is going to give us the value 735. So this is going to be the sum of the given arithmetic progression. Let's move on to the fourth and the final problem. So here in this particular problem, we have our first term. So let's consider the first to be represented by the letter A in uppercase. That's equals to A minus B whole squared. We'll expand this. This was going to give us A squared minus 2AB plus B squared. Then let's also find out the common difference. We'll express it by using the letter D in uppercase. This will be equals to the second term, which is A squared plus B squared. And from it, we're going to subtract the first term. So we'll have negative of the first term. So this is going to give us negative A squared plus positive 2AB minus negative B squared. So here A squared and negative A squared gets cancelled. B squared and negative B squared goes away. So we are left with positive 2AB. So this is the common difference. And we also have our nth term. So our nth term is A plus B whole squared plus 6AB. So let's first find out the value of n. So that means we have an equals to A plus n minus 1 times the common difference d. So we'll use this particular formula to find out the value of n. So our nth term is A plus B whole squared plus 6AB. That's equals to, so here we have A squared minus 2AB plus B squared. So this is the first term plus n times n minus 1 multiplied to the common difference, which is 2AB. So let's expand A plus B whole squared. So here we have A squared plus 2AB plus B squared plus 6AB. So we'll transpose A squared minus 2AB plus B squared to the left hand side. So we have negative A squared plus 2AB minus B squared, which will be equals to, so we'll have n multiplied to 2AB. So that's n times 2AB. Then we have negative 1 multiplied to 2AB. So we'll transpose it to the left hand side to get positive 2AB. So now let's further simplify this. So here we have A squared and negative A squared cancelling out, positive B squared and negative B squared cancelling out. So we are left with 2AB and 2AB. So that's 4AB. 4 plus 2, that's another 6. So 6 plus 6AB, that's going to be 12AB, which will be equals to n times 2AB. Solving for n, so we have n equals to 12AB divided by 2AB, or simply 6. So we have obtained our n value as 6. Now using this, let's find out the sum up to the n terms. So Sn will be equals to, so Sn is actually S6, which will be equals to 6 divided by 2, all multiplied to our first term, which is A squared minus 2AB plus B squared, plus the last term. This is our nth term, which is A squared plus, we are expanding A plus B whole squared, A squared plus 2AB plus B squared plus 6AB. So here negative 2AB and positive 2AB cancels out. 6 divided by 2, that will be 3. So we have A squared plus A squared, so that's 2A squared. Then we have 6AB plus B squared plus B squared, so that will be 2B squared. Hence, we have obtained the sum up to the 6 terms of the given arithmetic progression.